3D endoscope systems. 3D endoscope technology is becoming very popular within the medical world. However, 2D endoscope devices are predominantly used, as the 3D systems have not been perfected yet, and there are many new ways to improve it. Later, we will be hearing from a lead researcher in this field to hear about a 3D endoscope prototype that is being developed. What is endoscopy? During a medical procedure, a doctor will pass a flexible tube, called an endoscope, into a body orifice. This has a tiny video camera mounted onto its tip along with a small light, applied for better visibility. It can also contain a small tool for taking tissue samples or performing small surgeries. The Da Vinci device. The Da Vinci is a 3D surgical endoscope device. There is a large console where the surgeon will sit during the surgery. Here, the surgeon will view a magnified, high-resolution 3D image of the surgical site inside the patient's body. The patient cart has 4 interactive robotic arms, which the surgeon controls from the console. The instrument's joint wrist design exceeds the normal range of the human hand, with added motion scaling and tremor reductions to refine the surgeon's hand movements and decrease the risk of an error. There are some significant advantages to the Da Vinci system, mainly beneficial to the patient. This includes less pain, less blood loss, less need for a blood transfusion, shorter stay in hospital, and a quicker recovery time. However, the cost and size of the systems are huge disadvantages. We will now be hearing about new 3D endoscope prototypes that is being developed by a lead researcher, Salvatore Livatino. What is the new concept that you have designed?
So the new concept is to use 2 cameras instead of 1 on the tip of an endoscope. And this is expected to increase depth awareness on endoscope. And our focus is on flexible endoscopes.
There are different forms of endoscope devices. There are rigid endoscopes that are used in keyhole surgeries. And there are flexible endoscopes which are predominantly used within 3D devices. The flexible endoscopes are becoming more popular due to the fact of navigation through the patient's body. The camera mounted upon the end of the flexible tube will enable the surgeon to explore inside the body much easier than a rigid endoscope. How important is having 3D technology in the use of endoscope systems?
So, I think it's very relevant because 3D technologies brings higher depth awareness. Higher depth awareness means high realism, means higher comprehension of the observed world. So we have advantage in terms of higher accuracy, shorter sessions, because you understand better where you are, safer intervention, and thus it speeds up the learning of new surgeons.
Are there any drawbacks?
Well, the system is more complex, so we need 2 cameras, to use 2 cameras instead of 1. And also we need a 3D display to observe the environment. So the system in general is more expensive, more complex, and bigger.
Even though there are drawbacks to the 3D endoscopes, the advantages significantly outweigh the disadvantages. There are still improvements to be made to the endoscope systems, and the drawbacks are slowly becoming fewer and fewer. How do you plan to assess the advantages of the new technology?
Well, we believe there was a potential, and we want to build up a proof of concept. We want to see what kind of potential we have, what will be the real advantage. And we want to do this, we want to see what is the advantage of stereo compared to 2, so if it's true that 3D visualization is better in 2D and what is the improvement in the performance. And also we want to see how the performance vary, how the performance change when we use different technologies, because we know that 3D visualization is technology dependent. So the performance might dramatically change between one system and the other system. So that was our goal. And we want to, as a representative, we focused on the use of a bronchoscope. We thought it was a representative system. So the first step in our evaluation was to build a simulator when we can do extensive testing. The simulator would allow us to test with different users, to test with different systems, and to test with different 3D settings, so different position of the camera and so on. And how do we do this? We got a realistic 3D model of the bronch environment, of the bronch systems. So it means our model, our graphic model, because the simulation was a graphic model, was run on a graphic model, was built up from CT data. So we had a realistic setting. And then we ran a lot of evaluation, and we involved 7 systems. So we tried on different displays like laptop, desktop, big wall system, head-mounted displays. We tested with different approach to 3D stereo visualization. Colored anaglyph, polarized filters, shutter glasses, separate display. And we also use different type of display. We use LED, OLED, LCD, also the CRT, and we also use a DLP projector.
What are the results?
We had the number of tests, and then we had a formal evaluation with 20 test users, mostly students, and from our university. And we ran our test. We got a lot of data, we analyzed using the appropriate statistics, and the outcome, so the result, was very encouraging. We have a very great improvement in the performance, when operators use 3D visualization. 3D visualization is much better than 2D visualization, interestingly, regardless of the technology. So even if you use very cheap and limited 3D approach to 3D visualization, the performance are still very good. So, and also we notice big variation in performance with different systems, which were also reported. And we think all these results are very relevant for system designers to get to make informed decisions. Once we did all this, we had proved that there was a potential, and then we also, on a simulator, we want to try on a more realistic setting. So we built up a hardware prototype of our simulators, of our bronchoscope. And so this is our first prototype. It's an endoscope for engine inspections, which we have, of course, adapted. We put 2 7mm cameras that includes LEDs, and we try on a mannequin to see how performance would change between simulator and a real system. Later on, we progressed with a more advanced prototype number 2, when we use a more medical device, and we use much smaller camera. We have what was the smallest camera available in the market, 3mm, when we can use for processing, and a 1 LED. So we try this again with the mannequin, and this time we want to process the images. So our focus was on image processing, trying to get depth maps, and we want to do this because our more advanced phase of experimentation is to use augmented reality, so that the surgeon, when he's operating, is seeing the video in 3D of the remote environment, but also it sees can see some graphical element added.
As we have seen, there are many new devices and prototypes that are being developed to improve the world of endoscope systems, all leading towards using 3D technology to enhance them. We can only look forward to seeing these devices make a difference in the medical world and save lives.